Hi everyone, for today's video I want to show you how to build a 3D animated world in MATLAB and visualize your drone's flight simulation in MATLAB Simulink. The good thing is instead of building the 3D world from scratch, I just want to modify the 3D world that is already built in this example from MathWorks. This example has this animated world like such. All I want to do is just to replace this airplane here with a quadcopter. So I have to open this in editor. You have to save the SolidWorks model in STL file, and then you can import it into your 3D World um, editor. And this is the model I have been talking about. I can modify the scale of the drone. I think it's way huger than it should be. So I downscaled the drone here. Now I want to put the drone in the middle of the runway that we saw earlier. I can even change the color of the drone here. Now I want uh, to have a viewpoint that follows the drone while the drone is flying. So I have to add a route like such for this drone from the quadcopter to camera 1. Now I think we can follow. We can follow the drone while it's flying, and this is a good thing. Now I just have to save this world in my working path. We can also remove the airplane if we want, but that's not necessary. Now that I want to connect the world I just created into my Simulink model, I have to bring this stuff into my model. The good thing is you can just copy and paste these blocks I showed you from this example here in this visualization block, and you can just bring them here and do your flying simulation and your visualization stuff pretty easy. You have to change the source file. We choose the word that we just created, and then we have to mark the inputs of the word, namely the translation motion of the quad and the rotational motion. I think everything is cool here. Then we connect the signals accordingly. So this is gonna be the phi angle or the rolling angle, and this is going to be our pitch angle, and this is going to be the yawing angle. So I have already built 6 degree of freedom of a drone, of a quadcopter, and this here this interpreted MATLAB function is just functioning the nonlinear 6 degree of freedom, the equation of motion of the drone. So all I have to do now is just to connect these signals accordingly. Let's see what would happen if we run the model. And note that you always have to multiply the z signal with a negative 1 minus 1. Before running the model, we have to open this animated world here, and let's see what will happen. You can see that the drone is performing a circular path in a specific plane. Okay, it's over. Because you can see, as I provided the z, y, and x reference points, it's performing this circular path as defined here, and we saw that it has done its job pretty well. So that's it. Thank you for watching. Goodbye.